All right, so let's start talking about test 2 for intermediate algebra. So we got 20 questions to get through. This test, not going to lie, you got to make sure that you're on top of your stuff because some of these questions are very involved with the math and you got to make sure that you're on top of it. Otherwise, time will slip away really, really quick in this exam. Okay, so be extra cognizant of your time when you take this. So this whole exam is all about chapter 2 and chapter 3, which is systems, and then a little bit of long division, and then the rest is factoring. So question number 1 says, determine if each ordered pair is a solution. So you got, I believe, 2 parts to this, A and B. How can you tell if points are a solution or not? Yeah, that's right. You plug them in. Because points are made up of what 2 variables? X and Y. This is the X, this is the Y. So all we got to do is plug it in. Okay, so let's plug it into the top guy and see what happens. -2 times, oh, it says Y. Who's Y? -1, perfect. Plus 8 times X. Who's X? 3, yay. And we want to see, is that 26? If it's 26, then we'll plug into the second equation. If it's not 26, then we mark no and we move on and we'd be happy with life. So what is -2 times -1? Yay. Plus, what is 8 times 3? 24. So is 2 plus 24, 26? Yes. So far so good, but we're not done yet. We got to check the second equation to make sure that it's okay there. So we'll take this point, and now we will plug it into the second equation and check it. So we know the first guy's good. Now we're ready to check the second one. So that one's good. So -4. Oh, I see Y. What's Y again? -1. Oh, I keep forgetting Y's, X's. Plus 20 times, oh, it's X. What was X? Oh, okay. Equal to 64. So as long as we get 64 out of this, we have a solution. If we do not get 64 out of this, we select no and move on to be happy with life. -4 times -1? 4. Yay. Plus 20 times 3? 16. So the question is 4 plus 60, 64? Yay, it works. So is our point a solution, yes or no? Yay, so you select the yes. And then now we do part B and repeat the same process over again. Just going to take our point and we're going to plug in the X's and the Y's where they go. So who is X this time? -5. Yay. And the Y value must be then 1. So let's plug in. So we got -2 times our Y value of 1 plus 8 times -5 equal to 26. So -2 times 1? Yuppers. Plus, what's 8 times a -5?
-40.
Now the question is, if I take a -2 and add a -40, is that 26? No. Big fat nosies on that. So then down here, do I select yes or no? No, because it didn't work out. If that did come out the 26, then we try it in the next guy and see if it would have given us the right answer. Perfect, there you go. Part A is yes, part B is no. All right, moving on to the next one. Question number 2. So it says, solve the system of equations by graphing. So we want you to graph the 2 lines, and then you're going to tell us the intersection. Okay, that's what this means right here. State the point of the intersection. So here, this is where hopefully they gave you some help in your class where they taught you how to do some things on the calculator. So let's take this first equation right here. We got y equals negative 2x plus 2. Can I put that in the calculator? Yeah. As long as we have y equals, calculator is your best friend. If it wasn't a y equals, you could always solve it. So we bring up our calculator. Where do I go to start graphing things? Yep. Push the y equals button right up here above the second. And all we got to do is put in our equation, right? Yes. Which is what? Negative 2x plus 2. And again, down here, this is the negative button right here by the enter sign. Make sure that you use the negative button in front of that 2 in the very beginning, and do not use the minus button. There's a difference. So if we go over here and hit graph, there's what our line looks like. How do I get this information over onto my page?
Well, it says one, the points are 1, 0, and then 0, 1.
1, 0, and then 0, 1? Well, 1, 0 is right there. 0, 1 is actually right there. 0, 2. So you found the x and y intercepts, and absolutely, because if you remember, in here, down below your graph, there's going to be a list of commands. You got your little clear button that was over here, and then over here there's like a dot button, there's the line, then there's like I think like a circle, and then there's like a quadrilateral. No, not a quadrilateral. Think of geometry. A quadratic. So again, since we're graphing a line, you would actually come in here and click on this guy. And in order to graph a line, you have to click on 2 points. So you found 2 points. You found the x-intercept and the y-intercept. And so when you come down here and click on this guy, and then come up here into your graph, your first click sets the first part of your line. So you said 1, 0. And then as your cursor moves away, remember that line starts forming, and it moves wherever your cursor is at. And then when you finally click the second point, that solidifies the line. So right there is our line. It takes 2 points to make your line. As best as I could draw that. Does that make sense? Now, over here, just to also remind you, in our calculator, say you don't recognize, or it's not right off the bat that you see the x-intercept and the y-intercept. There's a place that you can go where you can look at a lot of points. Do you know where that is? Not trace. Not zoom. You're going to hit second and graph. What word is right above graph? Is table. So right here you have a list of infinite amount of points you can use. So there you can see the 0, 2. There's the 1, 0. Those were our x and y intercepts. But I could have graphed any one of these other points with another point and gotten my line. Because again, it only takes 2 points to plot the line. So if the x and y intercepts are not as apparent, go into your table and just grab 2 points that you know. Plot those. And there's your line. So all we do now, we have our first line. This is y equals negative 2x plus 2. Now we want to graph the second line. Can I put that guy in the calculator? Absolutely. So let's go into our calculator. Let's gear it up. Hit the y equals. We're going to clear that guy out. And what are we putting in now?
2x minus.
Okay. So 2x minus 6, hit graph, and there it is. And again, you can go with the x and y intercepts that you see up here, or you can hit second, graph, and there's a table of values you can use. It's all about what you want to do. Okay? Because again, how many points do I need to graph? 2. So when we come back in here, when you're doing the second line, You'll come down, you'll click again, and then all we got to do is put 2 of those points up there. So let's take a look at our graph. What is the x-intercept? 3, 0, absolutely, right there. What is the y-intercept? 0, -6, but yes. So if we come back here and look at our graph, this one will actually plot the point down there. So there's my first click. And again, as I move away, my cursor, you'll see the line bobbing back and forth. And then we do our second click, which this time is the x-intercept. And there we go. There's going to be our line. And to draw this as straight as possible, figures that would do that. There's what the line actually looks like. And all they want to know now is, so we did the first part, we graphed our 2 equations. Now they want to know, what is the point of intersection? Where do these 2 lines hit each other? And that's right here. Although I didn't graph it as great as what I could have, it is a nice point. What is that point there? 2, -2. And if you're on the calculator would also help you find that as well too. Just to review that real quick. So there's our second line. Let's go back in and put the first line back in. That was -2x plus 2, right?
No, it's, oh yeah, plus 2.
So if we look at the graph, those are the 2 lines we had. And here you can see that 2, -2. But again, on the calculator, you can verify that by going into second, trace, and you can use the intersect function. So if we scroll down to number 5, hit enter, this is where now it's going to ask you 3 questions down here. It'll say first curve, you'll hit enter, second curve, you'll hit enter, and then it will say guess. All you need to do to run this function is to scroll left or right to where the intersection is and hit enter 3 times. So I need to scroll to the right. That looks about right to me. And all I'm going to do is hit enter 3 times and the answer will magically appear at the bottom. And we're going to go 1, 2, 3, and there it is. Which verifies that it's 2, -2. And that is question number 2. Just some quick calculator work. All right, question number 3. So it says, given the following systems of linear equations, determine based on each graph if the system has 1 solution, 2 solutions, no solution, or infinitely many solutions. So when we look at this graph, it's basically just a multiple choice for all 3 of these. So if we look at graph A right here, what do you notice? They're not touching each other. So how many solutions can you have if they don't touch? None. None. Okay, so if we look at graph B, what do we notice? They touch once. That's right. They hit once right here. You can even see it. So how many solutions is that? 1 solution. And then finally in C, here's what we see. We only see 1 line. So what's the deal on that? What does that mean? There you go. There are 2 lines here. They just lie one on top of each other. So there's the first line. Here's the second line. They're both the same. So how many answers is that? Infinite, because they're both the same. Notice there was 1 answer up here we didn't touch, and that's the 2 solutions. Systems that we deal with, the linear systems, never ever will have 2 solutions. It's either 1, none, or all of them. So you can automatically eliminate 2 solutions for each one of these questions, because it ain't going to happen. All right. So now it says, now we're getting into solving the systems using methods that you like. Now, here's what I always tell my students. In here, it says use the elimination method. Most of your tests are probably either done on a computer or something along those lines. If you're doing this on a computer, does the computer know if you're using the elimination method? No. So if you like doing graphing, if you like doing substitution, you can do that on this. Okay, that's why we have more than one method. But I will tell you, in the end, the method that we're telling you to use, it is the easiest for this. Okay, so this says use the elimination method. I'm going to do the elimination method on it. Although we can do substitution on this. We can graph this if you know how to use a graphing calculator pretty good. But elimination is the best method for this. So in elimination, just as it sounds, you want to eliminate a variable. Which variable do you want to get rid of? The x. And most everybody wants to get rid of x. I don't know why. Maybe it's just because, you want to get rid of your x's, something along those lines. So in order to get rid of those, remember you have to have the same number in front. One of them has to be positive and one of them has to be negative. But we already got the positive and negative taken care of. I just got to turn them into the same number. So what number can I turn a 1 and a 6 into? 6. I can make them both 6. And just as I said a moment ago, you already have the negative up here, so don't change that. You already have the positive down below. So in the end, how many equations do I really got to manipulate up here? Just one of them, because this is the guy we have to manipulate. And what times a negative 1 will give me a negative 6? What can I multiply by a negative 1 to get negative 6? 6. That's what this entire equation up top is going to get multiplied by. We don't have to do anything to the bottom one because it already has 6x. 6x, it matches already. So don't forget, as a math student, we are multiplying this entire equation here. You should multiply 3 times. Where we sometimes mess up is we forget to multiply the end part. So make sure that you multiply all the way through. Well, we already know what's going to happen there. 6 times a negative 1 gives us negative 6x. What's 6 times a negative 4?
24.
Negative 24. Why? And what is 6 times a negative 2? All right. And then down here, we still got 6x. We still got the plus 24y equal to 12. Because we don't change the bottom guy because we already had what we needed. And so now that we're ready for elimination, what do? We do. So how do we start to solve it? What are we going to do with it? Yeah, we're going to start crossing stuff out. Stuff will cancel because we're going to add down. So you add down each one of these columns. So what's going to happen to the x's?
0.
We knew that was going to happen because we made it happen. What's going to happen to the y's?
0.
Oh, so everything over here on the left of the equal sign all canceled out, leaving you with 0. What happens over here? Oh. So everything canceled out. I'm left with 0 equal to 0. What does that mean for us? That means it's an infinite solution. Good. Because these are the same numbers. When your variables cancel out and you're left with the same numbers, like what we have here, these are the same. That means our solution is infinite, comma, infinite. Or in iMath they have you, it says the infinite symbol up there. Sometimes they have you for the infinite symbol, you put 00, comma, 00. Sometimes it tells you that. Okay? Feeling good? All right, next question. This time, we've done graphing, we've done elimination. The only one we haven't done is substitution. This problem is going to be a lot of fun with substitution. Okay? but we need to review substitution, so I'm okay with that. Just to be honest with you, I would not do substitution on this problem. I think elimination would be a whole lot easier. Okay? Again, you know, if you're on computer, is it going to know whether you do substitution or not? Nope. Unless your professor is wanting you to, you know, provide work and things like that. But, you know, I personally would not do substitution on this. But that's me. So, let's go with the substitution method. So, in order to apply the substitution method, we need to get a variable by itself. And in this case, it's dealer's choice. You can pick X, you can pick Y, and you can pick which equation you want to mess around with too. So that's the cool thing about systems is you got a lot of choice here. So you got to make some decisions. So do you want to work with the top equation or the bottom equation? Bottom one. Okay, we'll go with the bottom one. I like it too, smaller numbers. Okay, do we want to get the X by itself or the Y by itself? You want to get the X by itself? Okay. No, you want to get the Y by itself? Which one do you want, X or Y? All right, good choice. I would get the Y by itself too. Okay, so we're going to take this 8X minus 2Y equal to -4, and we're going to get Y by itself. How do we do that? Say it again. We can divide everything right away, but I'm going to save that for the end. First things, again, you want to get Y by itself. So who has to get moved away first? Yeah, I would grab this guy, move it away real quick. So how do I get rid of a positive 8X? Subtract 8X. Now, are these two numbers going to get together? No, they don't like each other. Don't put them together. So you got -2Y equal to, you can say -8X minus 4, or you could say -4 minus 8X. It's all the same. And then now we'll do what you wanted to do. We're going to divide by not just a +2, but a -2. Divide by a -2. I'm going to divide this by a -2, and I'm going to divide that by a -2. I always break it up. Okay? So Y equals, what's -8 divided by -2? Yay, 4X. What's -4 divided by a -2? All right. Now we have a variable that is solved. Now we can do some substitution. So we're going to take this 4X plus 2 and do what with it? Plug it into the first equation. For who? Okay, so the first equation, but who's it going in for? Is it going in for X or is it going in for Y? It's going in for Y because that's what we know. So we're going to take this guy right here and we're going to substitute it in. This is why we call it substitution. We're going to substitute it into the other one. We're going to take the 4X plus 2 and we're going to shove it in. We're going to replace it, however you want to think about it. You're going to take out the Y and put this guy in its place. Either way, it's all called substitution because we're replacing. So now we've got 16X minus 4. Oh, I see a Y. What's Y again? 4X plus 2 equal to 20. All right, so now we start solving. First thing is get rid of the parentheses. How do we do that? Yeah, you got to distribute. Yeah. Multiply that -4 through. You got it. You're talking about that. So 16X, what's -4 times 4X? Okay, -16X. What's -4 times 2? -8 equal to 20. All right, now what do we do? Combine like terms. So these X's are going to get together. What's going to happen to those? Boom, they gone. So all I have left is -8 equal to 20. What does that mean? That's a no solution. D and E, D and E. because these are not the same values. This doesn't make any sense. It's a way I kind of think about this is this -8 says I am in debt $8, and the 20 right here says you guys have $20. Are we really the same? No, because I owe someone $8. You guys get to go across the street to Taco Bell and have $20 worth of tacos while I sit at the window drooling. Okay, that's not the same. We're not the same. So this is exactly what you said. This is a no solution. But in the parentheses, you put DNE, comma, DNE. Okay? Alrighty then. And then they throw this guy. Again, this says perform elimination. You can do elimination. You can do substitution. You can graph this if you want. Lots of ways to do this. All right. You guys love fractions, right? I know you do. No, you don't love fractions. Oh. Well, okay. If you don't love fractions, then what can we do to them? We can make them whole numbers. We can get rid of them. This is what we call clearing the fraction. You're going to see this a little bit later on in Module 3 too when you get there. So clearing the fraction. You have done this before, just maybe or maybe not. Your professor might have said you were doing clearing the fraction. But what clearing the fraction is you're going to look at all the denominators up here. And you're going to multiply everybody by a common denominator. And that will clear the fraction out. So in the first one, our denominator is 2 and 3. 6. Multiply everybody by 6, and you now have a system of equations, and this top one that will be able to work as whole numbers instead of fractions. So everybody in here is going to get multiplied by 6. So you get multiplied by 6, and you get a 6, and you get a 6. Everyone's getting multiplied by 6. Cool thing is, your calculator can handle the fractions for you. So you go to your calculator, we'll take 6 times -1/2, or if you know that right off the bat. And if you don't, that's all right. That's why we got our calculator. So we're going to take 6 times, what was my fraction? -1/2. Where is the fraction key at here? Alpha. Not H. Y equals. Well, it should have popped up. So go over here. It should be alpha y equals. There it is. You hit alpha y equals, and here's your fractions. And you pretty much use the first guy. So you hit enter, and then all we got to do is put in the -1/2. -1/2. And what does that give us? So going back to our equation then here, we have -3x plus, what's 6 times y? 6y equals, well, what's 1/3 times 6? Well, again, we can just go into our calculator. Alpha y equals 1/3 times 6. 2. So there's our new upper equation, and it's easier to work with now because we don't have any more fractions. So let's fix the bottom guy. How would we get rid of that fraction? Yeah, because it's the only denominator. So multiply everybody by 5. So you get multiplied by 5, and you get multiplied by 5, and you get multiplied by 5. Everyone's getting multiplied by 5. So what's 5 times x? 5 times x. Yay! What is 5 times -2/5? You got it. Negative 2y equals, and what's 5 times negative 1? And now you're ready to go about and do your elimination or substitution, whatever you want. So, if we look at this, since we're going to do elimination, because I will go with the directions, who do you want to eliminate, the x or the y? All right, let's get rid of the x again. Let's get rid of our x's. So now, again, we already got the positive versus the negative, so that's good. We just got to turn them into the same number. What number can I turn 3 and 5 into? 15. So since the top is negative already, I'm going to leave it negative. On the bottom, we want the positive 15. So this time, since none of them match, we got to manipulate all of it. So up here, what can I multiply a negative 3 by to get negative 15? A 5. Good. And then down in the bottom, what can I multiply 5 by to get a positive 15? 3. So all we have to do now is multiply through our equations. So what is 5 times 6? Y equals, what's 5 times 2? 10. Okay, so there's our new top equation. What's 3 times negative 2? And what is 3 times a negative 5? Negative. And so now you're ready for elimination. And so for elimination, we're going to go ahead and do what? Down each one of these.
You're going to solve it.
Yes, which means that we need to add down each one of these columns. So what's going to happen to the x? Cancels out, which we knew was going to happen. What's 30 minus 6? So we got 24y equal to, what's 10 minus 5? Or minus 15, sorry. And now what do we do? Divide both by 24. Divide by 24. So y is equal to? All right, now unfortunately we cannot have decimals. Math AS does not want the decimal. So if we go to our calculator, we just want to know, does that division that we did reduce? So all division is just a fraction. So put in that negative 5 over 24, hit enter, and that is a reduced fraction right over there for the answer. So in other words, it was reduced. That is our y value. Nasty looking fraction. Unfortunately, this problem generates that. You're going to have nasty looking fractions. You're going to need to let the calculator do its job for you to help speed things up. So our y value is definitely negative 5 over 24. So if we think about what we've done so far, these things are going to intersect. You just found the y value. How do we find x? Yeah. All right, so we're going to plug in. And just as I always tell my class, I always tell them to plug into one of these because I know that the original equations are written correctly. I hesitate to plug into one of these because sometimes we have math magic on our side and we might get to that answer, but maybe one of these is written wrong, and usually math magic doesn't strike twice. So I always go back into one of my originals. And since it's a fraction, and my calculator can do fractions, I'm going to rely on my calculator heavy this time. So you can plug into any one of these. Which one do you want to plug into? The top one or the bottom one? The bottom one. Yeah, less fractions, right? So we're going to take this negative 5 over 24, and we're going to plug it into y right there. So x minus 2/5 negative 5 over 24, because that's what y was, equal to negative 1. And we're going to get x by itself. So this is where we're going to go to our calculator, and we're going to let it actually do the multiplication between these two. So we'll go to our calculator, alpha y equals negative 2/5, because it's a minus in front of that, which makes that number negative. And we're going to multiply that by our second fraction, which is negative 5 over 24. And what do we get? 1 over 12. So now we know that we have x plus 1 over 12 equal to negative 1. Now how do I get x by itself? All right. So now again, I'm just going to go to my calculator, and I'm going to let it do that information. We're going to take a negative 1 minus 1/12. So negative 1 minus alpha y equals 1 over 12. Hit enter, and there's the answer. So in the end, x is, you got it. And that's what goes into your blanks. That's what iMath.AS is looking for. Not the funnest, but that's it. That's the idea. All righty. So, moving on. Now you're going to be hit with a series of word problems. So, in this one, very, very important that you read, because the very last sentence right here says, do not solve the system. Do not solve. So all you're going to do is write the two equations. So when we look at this, systems come at you in one of two forms. They come at you as translation problems, where they're telling you mathematical symbols and words. Or they're going to come at you in a standard form type problem where they're giving you totals for your equations. If you have totals, you have standard form going on. Okay? So if we look at this, it says one number is 3 less than a second number. Right away I know this is translation. I see words like less than, I see is another word for equals. So if I look at the second sentence, it says 9 times the second number is 17 more than 3 times the first. So right away, I'm seeing mathematical words that I need to translate. Okay? So right here, this tells us about our variables. Let x represent the first number. Let y represent the second number. So it's very important that you use their variables. All right. So right here it says one number. Who is that? So x. I see the word is. What does that mean? Equals. And then it says 3 less than a second number. You need to be careful of this word right there. So what operation is less than? Minus. So what does this look like? And that's what a lot of people will put, but that is incorrect. That's why I said you got to be careful of this. Normally we do take it in the order that it's given, but the word less than right here means it is in reverse. The 3 goes after the minus sign. The second number, which is y, goes before it. So watch out for the word less than, because it does mean subtraction, but it's written backwards. Okay? So, looking at the next one. It says 9 times the second number. What is that? Okay. And then we see is, so what is that? Perfect. And then it says 17 more than 3 times the first. Yes, more than, it does mean addition. It is reversed. But because it's addition, you can actually get away with it writing it either way. But since we're thinking reversed on those type situations, let's keep that idea going. So it says 17 more than 3 times the first. What does that look like? So that's if you took it straight on, but remembering that more than means that it's reversed, which that answer was not wrong, but if we're going with the reversed information, it would actually look like that. 3x plus 17, because more than is just like less than. It's written backwards. And that's all they want. That's it. Okay? All right. The next problem. So now we're going to start solving. So again, as I look at this, I see words like sum, more than, times. This is another translation problem. So, it says the sum of two angles is 130 degrees. So what does sum mean? Sum? No. Plus. Addition. So you saying what? Okay. Equals, because of the word is. Good. And it's okay to use x and y here. Just make sure that you know which angle is which. So x represents first angle, y represents second angle, something along those lines, just in case they talk about some of that stuff in the later on. So usually when I do this, I use more specific letters. Like, say if we're talking about the first angle, I might call it F, and the second angle I'll call it S. F for first, S for second. But there's nothing wrong with x and y. Okay? So then now as we look to the next sentence, it says one of the angles is, so what does that mean? X, you see, is equals 5 degrees more than 4 times the other. So what does that look like? Okay? And again, if we're thinking more than, if we're talking about equation-wise, again, because it's addition, it doesn't really matter on the order, but more than is just like the less than, it's in reverse. So while this answer is good, I would take it. This answer is even better. Okay? So we need to figure out what the x and the y are. So, which means we need to solve the system now. And again, it doesn't tell us which method to use, so it's dealer's choice. What would be an easy method to use for this one? Yeah, I would definitely do substitution on this because we already know what x is. And I can take this, 4y plus 5, and put it where? Into the first equation right there. So, I see x up here. So that's 4y plus 5 plus y equal to 130. This guy right here used to be x, and then the plus y equals 130. All right, so what do we do now? Combine like terms. All right, so what's 4y plus y? 5y, good. Because there is a 1 that's in front of that y. So plus 5 equal to 130. Now what? Subtract 5 on both sides. Minus 5, minus 5. 5y equals 125, good. Because 130 minus 5, 125. And then what? Divide by 5, divide by 5. Y is equal to 25. Okay. And of course that would be degrees because it's an angle measure. All right, so now that we know y, how do we get x? Yeah, you can plug it into the second one, or we can plug it into the first one. It's your choice. Yeah, you can do either one. Doesn't matter. Second one would actually be a little bit faster because you don't have to do really any solving, just a little PEMDAS. But the first one is just as fast too, because it's like, if I plug into the first one, my x, we don't know, plus my y is 25, equal to 130. So what plus 25 gives you 130? Degrees. Now, in this one, I believe on your page it says which one is the larger angle, which one is the smaller. So just make sure that you put these in the proper blank. So the larger angle would be the 105. The smaller angle would be the 25. Okay? So once you got those two answers, just put them into the proper blanks. All right, again, another word problem. Very much like what you experienced in your homework. So there are 782 people at a play. The admission price was $15 for adults and $9 for children. If the admission receipts were $9,342, how many adults and how many children attended the play? Now, unlike what we saw a couple minutes ago, do you see any mathematical words in here? No. So this is a standard form. How do I know that? I have totals. Who are the totals up here? The people and the receipts. That's a total. That's a total. So I know for sure I have standard form. Because one of the equations is equal to 782. The other equation is equal to 9,342. Make sense? Okay. So, let's start figuring out some of these equations. So we've taken care of those numbers. Just so you know, once you use a number, you will not come back to it. So what do we think these equations are going to look like? Now remember, standard form is like ax plus by. So I need to figure out some sort of form for ax plus by here. I still have two numbers left.
So adults and then children. Adults are X.
Okay. Or if you want to change up the variables, we can call adults A, children C. That way I don't have to worry about who's who in the end. So, all right, so let's use A and C. I like that. All right, so what can we do with this $15 for adults and $9 for children? Put it in the second one. How'd you know that?
Because it's the amount or what the cost would be.
That's right. This number is all about money. These numbers are all about money and money. Your equation should make sense. This equation down here that's going to be in purple is going to be about money, money, money. So, what does this side look like using the 15 adults and $9 for children? Yes. Yes. Excellent. Look, money, money, money. And we've used these numbers, so we can't touch them again. So if we've used all the numbers and we can't touch them, what does this other equation look like then? Yeah, it's just going to be A plus C. And again, that makes sense because what is A about? The number of adults. What is C about? The number of children. People, people, people. That's what the 782 is about, people. It makes sense. All these equations make sense. Money, 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 people, people, people. All we got to do now is solve. So you can either do substitution, elimination, graphing, although graphing would be a little crazy because these are some large numbers. So what method do you want to do? Yeah, I would probably do elimination on this. Usually I only touch substitution if it's ready to go for substitution, like what we had a couple minutes ago. It's the only time I touch substitution. But I would do elimination. So who do you want to eliminate? The 15. So we're going to get rid of A's. All right. So now, and here we got to start thinking. So first I got to get them to be the same number. So there's a 1 here. What can I turn 1 and 15 into? 15. Make them both 15. Now, up here, the problem is that one of them needs to be negative now. And you have to make a choice. You pick. It's dealer's choice. The first one. All right. So now we know that we got to mess with this top equation a lot. The bottom equation, we actually don't have to mess with because it already matches. 15A, 15A. So the bottom one's good to go. It's the top one. So what times 1 will give me negative 15? Negative 15. There we go. So this top equation is going to get multiplied everybody by negative 15. So what's negative 15? We already know what A times A is going to happen. What's negative 15 times C? Negative 15C. Good. And what is negative 15 times 782? 730. Okay. Our bottom equation we don't have to do any messing with. It's all good to go the way it is. So we got 15A plus 9C equal to 9,342. So what do we do now? The A's are going to go away, and then we add down everybody else. So what's negative 15C plus 9C? C equals, what's negative 11,730 plus 9,342? All right, what do we do now to solve for C? You got it. Divide by a negative 6. Divide by a negative 6. C equals 398. And because it's C, we know that that is children. Okay. So now we know the children. We know that there are 398. How do we find A? Yeah. And you have two choices, either the blue one or the purple one. Yeah, I would definitely go with the blue one. That is the easier of the two choices. So all we're going to do is go into this blue equation up here, and it will be A plus 398, right? 98 equal to 782. So how many adults? 384 adults. Done. If you haven't noticed on these word problems that we've been working with, the one with the angle and the one with the children and adults, all of your answers have been positive and they've come out nice and neat. They should do that. They should do that on this exam, okay? So if you end up with an answer that might be negative or decimal, that means, hey, I've done something in error. We need to go back and fix that, okay? And the same thing will happen on this last word problem. You should end up with nice, neat answers for this, okay? So, and again, this is one just like that you've seen in your homework. So it says the amount of $780 is invested in two funds paying 5% and 2% simple interest. If the annual interest is $22.92, how much of the $780 is invested at each rate? So if you look up here, do you see any mathematical words? Nope. So this is definitely standard form. And again, because you have totals. Where are the totals?
780
Yes. Yes. Those are your two totals. That's what your equations better equal. Okay. Now, we just need to fill in. And again, we've used those numbers. We ain't ever going to touch them again. Okay? And this 780, again, it's already been used. That was the very first number, so that number's out too. So all we have left is this 5% and this 2%. Which one of these equations is going to go for, the purple or the black? How do you know?
Well, it's saying, well, that's what it's saying, that 780 is being invested into these things.
What is the 5% and the 2% about? Interest, right? Is that 780 about interest? No. Is that $2.92 about interest? So that 5 and that 2 should actually be with the black equation. Now remember, big note in this, we don't actually plug in percentages. We have to put them in as their decimal. So what does this black equation really look like? Point. Careful. 0.5. What do you want the variable to be? X. We can call it X, or I'm actually going to call it F for 5%. Then what? Plus 0.02 T for 2%, right? Because we're interested in knowing how much got invested at 5% and how much got invested at 2%. So, all right, we've used those numbers. Uh-oh, I'm out of numbers, but I still got to have another equation. What's it going to look like? You got it. And again, this all makes sense with what's going on. This is about interest, interest, interest. My top pieces, this is the money at 5, the money at 2, better equal all of my money. Money, 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 interest, interest, interest. The equations make sense. And now all you have to do is solve. And again, you can use any method you want. So what method would you want to use? Elimination? I would actually do elimination. Substitution works just fine, but elimination works, I think it's a little bit faster on this. Now, it's a little different this time because now it's like, oh my gosh, I got decimals and I don't know what to do with the decimals. It's not that hard. Okay, so let's go ahead and let's get rid of the t this time because you're always about getting rid of the first variable. Let's get rid of the second variable. So I want to get rid of t. So there's a 1 here and a 0.2 there. Whatever the decimal is, that's the decimal I'm going to make happen for both of them. So I want a 0.2 here, and I want a 0.2 here, because it's easy to take 0.2 times 1 and get 0.2. Okay, if I wanted to get rid of f, what number would I make both of those? 0.05. Okay, because all I would have to do is multiply this top equation by 0.05. So, and again, both of these are positive. I need one of them to be negative. Who's going to be my negative? I'm going to make it the top one. So that way, all I have to do is multiply this top equation by a negative 0.02. The bottom equation will just stay the way it is. So all we got to do now is multiply. What is negative 0.02 times f? Negative 0.02f. We already know what's going to happen when we multiply the t. We made it that way. What is negative 0.02 times 780? Negative 15.6. My second equation There's no messing with it. You leave it alone. 0.05F equals 2292. And what do we do now? Add down, because my t's are going to cancel out. So what is negative 0.2 plus 0.05? All right, so 0.03F, t's are gone, equal to, what's negative 15.6 plus 22.92? 7.32. All right, how do I get F by itself? Divide by 0.03, divide by 0.03, and F is equal to 244. So $244, and that will be at 5%. See how I told you all these word problems are coming out to nice numbers? They're positive. So good. All right, now how do we figure out T then? Yeah, come back up here, take that F and plug it into one of these two, either the purple or the black. Which one's the easiest? The purple one. Yeah, why mess with the decimals? Go back into the purple one. So we're going to have 244 plus T equal to 780. What's T have to be? 536. So $536 at 2%. There's the answer. And again, you could have done substitution on this one too. Take the top equation, solve for one of those variables really easily, and then plug it into the other guy. All right, that right there takes you through almost all of chapter 2. We got a little bit left. We have an inequality right here that we need to graph. And I believe after that one is a system of inequalities. And then we jump into chapter 3. Again, like I said, this is a long exam. There's lots of information and detailed in it. Make sure that you keep, cognizant of your time. So we want to graph this linear inequality. All right. How are we going to do that? Say it again. We are in standard form. X and Y on the same side, that's standard form. That's the form we want. We want Y equals. But that's not called standard form. That's called slope-intercept. So yeah, the first thing we want to do on this is we want to get this Y by itself. So what do we do first then? Absolutely. Take this negative 1/2 x, as you said, and add it to the other side. Plus 1/2 x plus 1/2 x. So you have negative y less than, and you can say 1/2 x plus 1, or you can say 1 plus 1/2 x. It's your call. Now what are we going to do? Oh, so I got this negative y. You said I had to flip it. Why would I flip it? Why? And flip what? So flip the sign. So this sign, or these signs? Both of them, yeah. What you need to do is we need to divide everybody by a negative 1. And remember with inequalities that if you divide by a negative, the symbol has to change directions. So negative 1/2 divided by negative 1, positive 1/2 divided by negative 1 is negative 1/2 x. Positive 1 divided by negative 1 is a negative 1. There's our equation. And now all we're going to do is we're going to go to our calculator. We're going to let it do its job. Okay? So, in our calculator, clear all that information out. Clear out my previous equations. How do I show this inequality symbol in my calculator? Yeah, there's going to be shading on this one. So how do I tell my calculator to shade? How do I show that greater than symbol in my calculator? Go over the equals. A little bit further. Go to this guy. And there are two symbols down here on the line. The symbols you're looking for are either the upper triangle or the lower triangle. Okay? Those triangles tell your graph that you need it to shade. Okay? So the lower triangle, this is the symbol that's used for less than symbols. The top tier triangle right here, that's the symbol that's used for greater thans. So since our symbol is greater than, that's the symbol we want. We're going to come down and we're going to say OK. Now our calculator will shade for us. And then all we got to do over here is put in our equation. Does that make sense? So how do I put in my fraction again? So we got negative, and then what? Alpha, y equals. We want that 1, and then it is 1/2, right? Now what do we put? X, don't forget the x, and then minus 1, right? And then we go over and we hit graph, and boom, there it is. And so we talked earlier about how we can take and get this information onto our picture. Okay? So what can we do from here? How can I get this onto my graph? Find 2 points. Where can I find points at on the calculator? The table. How do I get to the table? Second graph. And then you can find points that you can use. Don't pick anything with a fraction in it. Pick the ones that have nice points. Like, for instance, I've got -2, 0. I could use that one. I've got 0, -1. I've got 2, -2. And I can scroll any direction I want. Oh, look, I've got 4, -3 here. Just grab 2 of those. Okay? And remember that in iMath.AS, when you do this, again, you have that screen that's down here, and there's a clear button, and then again, you have your point, your line, I believe there's a circle, and then the quadratic. And just as you said, you only need 2 points to make your line. So, what 2 points do you want me to graph? 4, -3, okay?
And then
0, -1. Now, the other thing that you have to be careful of in this one is because we are on an XY plane, we show open and closed circles or brackets and parentheses since we're in college. We show those a little differently. How do I show if this is supposed to be a bracket or a parenthesis line-wise?
Well, since it's less than, it's going to be.
It's actually not a less than anymore, it's a greater than. But yes, because of this symbol, what does that mean for us? It means open circle when you were in high school. It means parenthesis for us in college. But on a graph of a line, it's what? Dotted. Remember when we're graphing these are the solid or the dotted lines. And because of this symbol, that means that we are dotted. If we were equal to, then it would be a solid line. So you need to make sure that you know that. So if I come over here, this is actually what your line will look like. You already know where all the shading is going to happen. And the shading happens all up here, right? And there you go. Okay? Yeah. Of course you got to shade because this is an inequality. That's why we went through the steps and told our calculator that, hey, I wanted to see shading. because that's important to us. Make sense? So there we go. There's our answer. Cool beans? Now, in IMath a couple things. IMath will not give you the solid or the dotted line capabilities, and sometimes it doesn't do the shading very well. So what could happen is, in IMath when it talks about the line, you'll have a drop-down box, and inside it, you will either select solid or dotted. Okay, so it's a drop-down box when it says talk about the line, because IMath will not draw solid or dotted lines. And then the other thing, usually there's a drop-down box, and it will say, did you shade the top or did you shade the bottom? So did we shave above the line or down below the line? Okay, so you choose top. Or the other thing that it will do is it might give you an extra icon in here of a paint can that's tipped over. And you'll click on that and you'll put the paint can in the area where the shading should appear. So I've seen kind of those things happen. So be aware of that. Last but not least, we got a system this time. Cool thing they did for us, and this is the last question in chapter 2, but we're still not done. We got chapter 3. Like I said, a lot of information. Okay, best part about these is these are all set, ready to go into our calculator. Okay, and they're going to graph and shade the same way. So again, it might ask you some questions about your lines. It might say, hey, are these solid or dotted? So we can look at these right away. What is line 1 right here going to be, solid or dotted? Solid, because we're equal to. Line 2 right here, what is it going to be? Solid as well, because we're equal to. Okay? So we can go to our calculator. So because we are less than or equal to this time, for my first equation, do I need to, when I go over here to pick my symbol, do I want the top triangle or the bottom triangle? The bottom, because we are less than this time. So now we'll say okay, and then all we got to do is come over here and put in our equation, which what is our equation? So negative alpha y equals 1 over 2 x. So negative 1/2 x minus 3. And there's our graph. Okay? So again, you can graph this looking at the x and y intercepts, or you can go into the table and grab your 2 points. Let's just go ahead and speed things up by using the x and y intercepts. What's the x-intercept that's right here? Okay, and what is the y-intercept? 0, -3. So let's just graph that real quick. -6, 0. And then 0, -3. Slide down some. So here's what our, oops, it's changing on me. There we go. Here's what our line looks like. And where did it shade? Below. Yay. Woo! There we go. And now we'll go in. We'll do the same thing for the other guy. So we'll come in here. I can clear all that out. So because we are greater than or equal to, do I want a top triangle or a bottom triangle? Top triangle. There it is. And then all we got to do is put in our equation, which is what? 3x plus 2. Graph. And again, we can use our x and y intercepts on this. What's our x-intercept right here?
That is
0, 2. Actually, let's just make sure on this one. So at negative, so we got 0, 2. Notice our x-intercept we might have thought was negative 1 comma 0, but it's really not. It's not on here. So this is where it's a good idea to make sure that you have that table available for you, because we actually couldn't use the x-intercepts on here because there isn't one up here. So maybe we use the y-intercept, which was 0, 2, and this guy, which is negative 1, to help us graph. So 0, 2, negative 1. So all I got to do is start making my line now, which would have formed anyway if you're in iMath AS. And then where did this guy shade? Actually, I'm going to change up the color on this because it's going to be important for us to see things. Stop it. Oh, gosh, you silly thing. So let me change up this color real quick because I want you to be able to see some things. Let's make it blue. Kind of, sort of. Let's make that blue. You do? Me too. Stop it. Oh, I don't want that. Yes, there we go. Blue. Make sure that I'm in blue. All right, where did this guy shade? To the left side of it, right? All right, so we go over here. This guy shades to the left. And so in here, when you're solving systems, it's all about where is it that the colors overlap. So in my picture, where is it that I have both blue and purple? In this bottom left part, right? So this is the section that is considered the solution area, because that's where I have both purple and blue. And again, your calculator can show you all that information. So I shouldn't have probably deleted out the other guy. But let me get it back in there real quick. Want the bottom triangle this time. And this was negative alpha y equals 1 over 2 x. And it was minus 3, right? So right there you can see that section that we highlighted, which up here, when you're using those color calculators, I like that a lot because it almost kind of turns it purplish. So kind of cool that you can use that feature on your color calculators if you get to borrow one that is colored. Okay? And again, in iMath AS, they do a couple things. They might want to know where they intersect. So you can use your second calc, go down to intersect, scroll over to the intersection and hit enter 3 times for it to do its magic. So close enough. 1, 2, 3. And there's the intersection, which since this one's a decimal, it probably will make you round. Okay, so it might ask for the intersection. But then it also might have the following question as a drop down. There might be a drop down where it says, is it in the top, the bottom, is it left or right? So here's the top, bottom, left, right. So in the drop down, you would select left. Or again, it might give you that paint can option, and you just drop the paint can in that section. So lots of ways iMath.AS may throw this at you. Okay? That right there ends chapter 2. Now we're in chapter 3, where it's a little bit of long division, and then nothing but factoring. So right here, we want to perform long division. So where does the numerator go? Does it go under the division symbol or out in front? Under. So, and as you write this, make sure that it is in standard form, meaning from the highest power on down. And if you're missing any powers, you have to put a 0 in its place. You've got to keep track of that. So there's what is underneath the division. So that means the denominator then must go in front. All right. So long division is just like regular division of numbers. Long division is just like regular division of numbers. So we're going to ask ourselves, what times the 2x will help us get rid of the negative 10x cubed? A negative 5x squared. Good. And that's what goes up here, because that's your first step. Your first step is all about trying to figure out, how do I get rid of this guy? So a negative 5x squared will help us get rid of that. And then now we're going to take that negative 5x squared and we're going to multiply our polynomial in front. So what's negative 5x squared times 2x? And that's no surprise to us. We knew that was going to happen. But what is negative 5x squared times 1? Negative 5x squared. Good. And then now, in division, all we do is subtract down. Or, depending on what your professor might have taught you, because you're subtracting down, that means you can also change these signs and just add down then. Okay, it's your call. I always just use it as subtracting down. So we know that these two are going to cancel because we engineered it that way. But what's going on over here? Well, we have an x squared minus a negative 5x squared. That's the subtraction that's going on. An x squared minus a negative 5x squared. Those of you that change your signs, you don't worry about the minus anymore. It's just put it together. So what happens with two negatives by each other? So what is basically x squared plus 5x squared? 6x squared. And then everybody over here does what? Comes down. It trickles on down like Tetris. Da, na, 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 na. All right, moving on. So now we have a new number we want to get rid of. So we need to think to ourselves, too far up, what times 2x will give us 6x squared? Positive 3x, I agree. Positive 3x. And we multiply again. 3x times the 2x plus 1. And that's not surprising. We knew that was going to happen. 6x squared. And then plus a 3x. Perfect. And then long division says subtract down. So we know that those guys are going to disappear. Oops, go back, 6x squared. Then what we have here is 51x minus 3x. So what is 51x minus 3x? 48x, okay. Plus 14, because it trickles on down. And repeat again for the last time. So now we've got one final guy to get rid of, the 48x. So we think what times 2x will give us 48x. How much? 24? Positive or negative? So up here we say plus 24. And we come down here, we do the multiplying. 24 times the 2x plus 1. We already know that this was going to be 48x. But what's the next part? What's 24 times 1? 24. And we subtract down. So we know the x's go away. We have 14 minus 24. That's what you're really subtracting. 14 minus 24. What is 14 minus 24? Negative 10. And now you have all the information you need for the iMath AS. Because in the one blank, it'll say, what is the quotient? And that's everything that's up here. So this guy right there, that is the quotient. Negative 5x squared plus 3x plus 24. And then in the second blank, it says, what is the remainder? That's the negative 10. Now, please know, again, that's not really how this answer should be written up. The real answer should look like negative 5x squared plus 3x plus 24 plus the remainder over 2x plus 1. Or if you want, you can take the negative and put it in front and say it's minus the 10 over that. That's how the answer should really look. But in iMath AS, we make you separate it out into the quotient and the remainder. Okay? Everything else from here on in is factoring, 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 factoring. So this first question, question 14, is all about GCFs. So when you look at this problem, when you think about GCFs, there are two types. There are numbers and there are variables. First, the numbers. I always tell my students, if you're looking for a number GCF, it has to be a number that can divide all of these. And we want the biggest because it is called a GCF. It is the greatest common factor. So what is the biggest number that will divide 76, 52, and 116? Is it what? 4? I don't know. I'm relying on you. 5, so just 5, only just 5, 6, and 7. There can't be anybody bigger than? Oh yeah, you try and find the biggest. I need the biggest number that will divide all these. If 4 is the biggest one, I'll go with that, but I don't know. I don't think it is the biggest one. It might be. And you are correct. 4 is the biggest one. But you should always double check that. You should always make sure. So all these numbers can be divisible by 4. Or can be divided by 4. Okay, then we look at the variables. Do all these have a common variable? Yes. So since we said yes, we're going to pull that variable out. Now, the most amount of variables you can pull out, the most amount is the smallest exponent. What's the smallest exponent on x? 7. So that's the most amount of x's I can pull out of everybody, that everybody can cover. So all we have to do now is write down what's left. So remember that all these numbers got divided by 7, and all these variables had 7 x's taken out of them. So what is 76 divided by 4? 19. There were 15 x's, but I pulled out 7. 8 x's left? Perfect. What is 52 divided by 4? 13. There were 9 x's, I pulled out 7. 2 left. What is 116 divided by 4? How much? 29. There were 7 x's, I pulled 7 out. Nothing left. There we go. That's completely factored now. Okay? All right. Almost done. So question 15. This one, it tells you exactly what to do. It says factor by grouping. Factor by grouping. So when you learn factoring by grouping, what's the first step you're going to do? All right. Who are we grouping? We can group. Say it again. You group the first one with the second one. We group the first 2 together because they actually have something in common. And then who else do we group? We group the last 2. This is why we call it grouping, because we're going to group the first 2 and we're going to group the last 2. And now all you do, grouping is just a giant GCF problem. So we're going to look in this first parenthesis. What's the GCF in here? What can I take out of it? What do both of these have in common? A y. So we're going to pull the y out. And what's left after I pull the y out of that? The x plus 8. Because all I did was pull the variable y out of both of those. Now, the cool thing with grouping is whatever you have left in this first parenthesis right here, the second parenthesis has to match it. So since I have x plus 8, there's going to be a GCF that I pull out of here that will leave me with x plus 8. Or another way to think about this is, what times x brings me back to a negative 6x? Negative 6. And the negative 6 was actually the GCF that you would have pulled out of there if you'd gone through and looked at it. So there's another way to kind of cheat the system of grouping. Once you know what the first parenthesis looks like, the second parenthesis has to match 100%. And then you just think about it as multiplication. What times the first term gets me right back to where I was? And that would be the GCF. But we're not done. We're almost there. So there's one more step. When you do grouping, you're creating 2 parentheses. One of these parentheses is the parenthesis that got repeated. So one of them is what? X plus 8. The other one represents the GCFs that you pulled out. So what are the GCFs we pulled out in order? Y and negative 6. Now it's fully grouped. Grouping is just a giant GCF problem. That's all it is. And there you go. Cool beans? All right. So we want to factor the trinomial. So there are 2 of these back to back. The difference between these, this one makes factoring a little bit easier because your a is 1. But in the second guy, which is number 17, your a is not 1 anymore. So it makes it just a little bit more challenging. So let's talk about factoring with trinomials. Hopefully your professor kind of gave you a couple different ways to factor. What are some ways that they have given you to factor trinomials?
Well, they gave me like an X, and I put 16, and then the bottom.
Okay, so you're going to play some X games. And then what do you do after that?
You see what times, something times is going to get you 16.
All right. So let's start walking through this game. So what you're talking about is the X games. This is how I talk to my students a lot about it. So in the X games, it's set up like this. There's an x. On top here is the a times c, and down here is your b. So remember that all polynomials, when it comes to quadratics, they're written in this form. This is what we call standard form for a quadratic, quadratic polynomial. A is always in front of the x squared. B is always with the x. C is always the guy without a variable. So if we look up here, who is A? No, it's 1. It's the number in front of it. It is 1. Who's your B? Not just 10, but a negative 10. You include the signs. Who is your C? 16. Now that you know your A, B's, and C's, we can jump into the X games. So in the X games, up here is whatever A times C is. So we're going to take 1 times 16, and that gives us 16. Down here, you're going to put B. What is your B? Negative 10. So what you're doing is you're looking for two numbers. And these two numbers, whatever they are, they must add to the bottom and multiply to the top. Well, we can narrow down that search because there's like tons of ways to do that. We narrow down that search by looking at this top number. And you write down the factors of 16. So factors of 16 are like 1 and 16, because 1 times 16 is 16. What's another factor of 16? 8 and 2, and I'm going to write it 2 and 8. Are there any other factors of 16? Say it again. 4 and 4. And notice that as you write these factors down, as these numbers go up, these numbers go down like they're honing in on each other. So the closer these numbers are, then you know that you will not have any more factors. Like for instance, I got to 4 and this guy over here is 4. I stop because there are no more factors because I'm at the same number on both sides. So the closer they are, the fewer numbers that you have to check. And so these are all the factors of 16. So somewhere in here, there's a way that I can take one of these factors and get a negative 10. How can I get a negative 10 out of 1 and 16? Or is it 2 and 8? Or is it 4 and 4? How do I get the negative 10?
Negative 2 plus negative 8.
There you go. A negative 2 and a negative 8 will add together to give you a negative 10. And if I take negative 2 times a negative 8, that is a positive 16. So far so good. Now what? What do I do with this information? Well, you can do a couple different things. Some of you learned slide and divide, and you can do slide and divide. Some of you will learn what I call the AC method, which is basically going through grouping. Because what you have done is these two numbers right here are how this middle term break apart. So you could set up grouping. Some of you might learn a box method, things like that. So I'm curious to what you're writing.
Oh.
Okay, I know what you're doing now. Okay, so I know how you were taught. You do the AC method. So the AC method now, we're going to take what we know and we're going to set up grouping. So we're going to keep this guy right here and this guy right here the way they are. So we've got x squared, and then down here we have plus 16. And in the middle go these two values. That's why we played the x games, because these two values still equate back to this guy. So negative 2x and a negative 8x. Because if I put those back together, that's still negative 10x. So see how we have 4 terms? Whenever you have 4 terms, you do grouping. So we group the first 2. We group the last 2. What's going to come out of the first parenthesis? An x. What is that going to leave us with?
X minus 2.
And again, as I told you in grouping, this second parenthesis has to leave us with x minus 2. So what times x gets me back to a negative 8x? A negative 8. So now all we got to do is write out what we know. What is the parenthesis that repeated? X minus 2. What are my GCFs? You have now factored. There are some shortcuts. Yeah, and there are lots of ways to solve factoring. Okay? But this works mathematically 100% every time as long as you follow the steps. Yeah, when your A is 1, this factoring kind of seems redundant. Okay? But when your A is not 1, you're going to thank me for knowing that method. So, let's run through this again. So what's your A? 33. What's your B? What's your C? So the X games up here, again, is A times C. Down here is the B. So what is A times C?
A
little bit larger, but that's okay. And down below is what? What is our B? 16. So we want to find two numbers that when multiplied will give us negative 132, but when added together give us a positive 16. Again, focus in on the top number. Don't worry about the fact that it's negative. We'll deal with that later. Just right now, focus in on 132, and we need the factors of it. Let me show you a fast way to get factors. Because I know a lot of you are like, oh, how many times do I gotta do what, Mr. Armstrong? I gotta think about everything. So if you want to find factors really quick, go into the y equals. And what I want you to do is I want you to push 132 divided by x. Then go look at the table. Hit second graph. Right here, only focus in on the positive ones.
This was all like this the whole time.
Yep. And right here, anybody that you see come out to a nice number, those are factors. So 1 times 32 is 132. 2 times 66 is 132. 3 times 44 is 132. So here's a fast way that you can look. And notice right here is where you would actually stop. Because we don't want to go past 11 because our next number over here was 12. We're already honed in on each other. So here you're looking at all the factors. And the ones that we care about are 1, 2, 3, 4, 6, and 11. Because 7, 8, 9, 10, these are all decimals. We don't care about those. And same thing for number 5. You only care about the ones that come out nice and neat. So let's write those out real quick. So we had 1 and 132. We had 2 and it was 66. 3 and 44. Did we have 4? Yeah, 4. 33. I know 5 was not a part of it. 6 was, though. 6 and what? 6 and 22. And then it was 11 and 12. So somewhere in here is a way to get negative, or is a way to get 16. How? Okay, so one of them will have to be negative, one of them will have to be positive, obviously. Yeah. So who is it then? Where am I going to get the 16? the 6 and the 22. How is this going to work for us? It does matter. I want a positive 16. There you go. And if you notice, negative 6 plus 22 is a positive 16, and a negative 6 times the 22 is a negative 132. That's why I said don't worry about the sign. It'll come in later on. So now all we got to do is grouping. It does matter, because if I put the negative on the 22, that would have been a negative 16. And I don't want a negative 16. I want the positive. And again, that would give us a negative 16, but that's not what we want. We want the positive 16. Okay? So it does matter. So again, now that we're going to do grouping, we're going to keep the beginning and the end the same. So we're going to have 33x squared, and then over here a negative 4. In the middle, you're going to put your two numbers that you found. This is what goes in the middle. Negative 6x, positive 22x. And all we do now is group. What is the GCF that will come out of the first parenthesis? 2x. Yeah, even bigger than, well, actually 2 couldn't work because 33 couldn't be divided by 2. But I like the 3, yes. We're going to pull out a 3x. And what's that going to leave us with? Well, what's 33 divided by 3? 11x. So whatever we pull out of the second parenthesis has to leave us with 11x minus 2. So what times 11x gives us 22x? Say it again. A positive 2. So now you know what this factors to. What's the first parenthesis going to be? So 3x plus 2, there's your GCFs. What's the second parenthesis? Doesn't matter. I can have the 11x minus 2 first, and then the 3x plus 2. Okay? Whoops. Come back. There you go. That's factoring. Notice, now this part wasn't as redundant as what you saw a couple minutes ago, because A was not 1 in here. Notice none of these numbers right here popped out down there. So that's why, you know, when A is not 1, that's why I like the AC method that we did right here, because it's a surefire mathematical way to get there. There's no guessing or anything to it. I know, that's why I'm awesome, and they show you things like that. All right. So, last couple questions. So right here, we are factoring this polynomial. First off, I'm going to give you, a quick heads up on this. You can do exactly what we just did a couple minutes ago. AC method on this. This really is 3 terms in disguise. Remember how we talked about long division, that if we're missing a term, what do we put in its place? 0. So this goes 2 to 0. So that means we're missing the 1 term, right? So you can think about this as y squared plus 0y minus 121. That's what it looks like in standard form with everybody in. And you can do exactly what we just did. Okay? You can run the AC method and get to the answer. But I'm going to show you a faster way. Okay? What you're dealing with in this problem is what we call a difference of squares. When you have a difference of squares, it looks like this. There's always subtraction somewhere in it, and your numbers that you're dealing with are what we call perfect squares. And in the end, this is how it will always factor. A plus b, a minus b. So I call this method the square root method. Because these are perfect squares, that means I can take the square root of them. So here's how this works. I'm going to take my first term right here, and I'm going to take the square root of it. What's the square root of 9 going to be? 3. What is the square root going to do to a square? Cancels it out. So I'm left with y. That's A. Now I'm going to take the square root of my second term, which is 121. Ignore the minus. So the square root of 121. What is the square root of 121? It is 11. That's B. All you do is you fill in the parentheses. So in my parentheses, one is a plus, one is a minus. It doesn't matter which one is which. And what goes at the beginning of your parentheses and before the minus and before the plus? It says A. What was A again? So I'm going to take 3y and I'm going to put it right here in the A spot because the 3y was A. After the plus sign and after the minus sign, go what variable? The B. Who was B? 11. Put the 11, done. Again, there's nothing wrong with doing the AC method that we did a moment ago, but I like doing this. It's called, I call it the square root method, and it's just quick. Take the square root of your first term, take the square root of your second term, that's the A and the B, and the difference of squares. And all you do is you fill in. Okay? One of your parentheses is a plus, one of them is a minus. The same thing's going to happen for these last two. Same thing's going to happen for these last two. So you're looking at cubics. Okay? Cubics have a very, very straightforward form. It's a formula. And it's going to work a lot like what we just saw a moment ago, but instead of being square roots, we're going to do cube roots because we are dealing with cubics. Okay? So, cubics come in two forms. This form that we're looking at here is what we call the difference of cubes. Number 20, if you look at it, between my two terms is a plus sign. So that would be called the sum of cubes. All right. So, difference of cubes, sum of cubes. This is how it breaks down. Difference of cubes looks like this. You got an A cubed minus a B cubed. And here's how the formula falls out. And it factors this way every time. There's no change to it. So, unfortunately with the cubes, you need to know these forms. There's no way around it. So it looks like this. A minus B in the first parenthesis. So it's like we undid all the cubing. And then over here in the second parenthesis, it looks like A squared plus AB plus B squared. Once you know what the A's and B's are, you're just basically filling in, which is like what we did a couple minutes ago when we had the difference of squares. When you take the square root of those first and second terms, you're finding A and B. It's the same idea, except instead of square roots, we're doing cube roots. So my first term is y cubed, and I want to take the cube root of it. What's a cube root going to do to a cube? Cancels it. Just like what happened before, how the square root took care of the square. So the cube root and the cube cancel out, and you're left with y. That's A. Now we're going to take the cube root of the second term. Cube root of 27. In your calculator, if you don't know where the cube root is, clear that out real quick. Under math, it's right there at number 4. So you hit math, scroll down to number 4, hit enter, and all you got to do is push 27. And enter one more time. And now you know what B is. All we have to do now is go over to our little formula over there and fill in. So this first parenthesis has a minus. First part right here is A. What's A? After the minus is B. What goes there? So there's your first parenthesis. And then now we fill in the rest. This first piece right here is what A squared is. So you take the y and square it and get what? Y squared. Plus, you're going to take the A and B answers and multiply them. What's y times 3? 3y. Plus, and now you're going to take the B answer and square it. What's 3 squared? Answer. It's just a straight formula. Plug into that formula, kick out your answer. Okay? Same thing's going to happen on this guy, but instead of a difference, it's a sum. So let me show you what that formula looks like. So in the sum of cubes, you've got a cubed plus b cubed. Here's what the equation looks like. So the first parenthesis is now a plus b because you're dealing with a sum. And then the second parenthesis, it's going to look a lot like what we just had with one small little difference. It'll be a squared minus ab plus b squared. The only difference between these formulas is what symbol you have here and there. That's the only difference. In the difference of cubes, it was a minus and then the plus. In the sum of cubes, it's a plus, then the minus. That's the only difference. And then we're going to do the same thing again. I'm going to take this first term, and I'm going to run the cube root of it. So what is the cube root of 64z to the third? 4z. That's a. Then we're going to run the cube root of the last term. What is the cube root of 125? 5. Good. That's b. All we do now is plug in. So this first parenthesis says a goes before the addition sign. So what is a? Says b goes after the addition sign. There's your first parenthesis. And then all we do is we plug into the rest of it. So here, after the parenthesis, it says a squared, which is?
B squared is 4.
Careful, you got to square it. 16z squared, because you're squaring this a. So 4 squared is 16, and z squared is z squared. And then it's a minus, and now it says multiply the a and b. So you get 20z, because 5 times 4 is 20. So 20z, and then plus, all you got to do now is square the b. 25. And done. That is what your exam is going to look like for test 2. Again, there's a lot of information. You got to make sure that you are well aware of that time when you go through this. Okay? If you are getting hung up on a problem, skip it and come back to it. All right? Good luck.